Hello, everybody.
Hello.
Hello.
There are seats up front, so I'm patient. If you guys want to meander your way, don't feel like the outcast, like, oh God, I'm going to be that guy that's got to walk all the way up to the front. I can't invade. Don't worry about it, it's cool.
But we will have you on camera.
Yes, it will be on YouTube forever. You'll be that guy. All right. So let me give you a little background on myself. Again, my name is Douglas Mallette. I am currently the CEO of Cybernated Farm Systems, a company I just started a few months ago with the lofty goal of nothing less than solving the global hunger crisis once and for all, using 21st century technical innovation and not resorting back to 17th century old school agricultural practices. It doesn't work so well. I'm a former space shuttle systems engineer. I used to work with a subcontracted company to Boeing in Houston, Texas. And I'm also the author of Turning Point, a layman's guide to why space exploration and development matters to your everyday life. Sadly, more people know about Lindsay Lohan than they do about how well the space exploration and space industry has advanced their quality of life on a daily basis. So I decided to write a book that kind of sums it up and gives people a better perspective and also a greater respect for what space exploration actually means. So what are we going to talk about today? Well, we're going to tell a little story. And the story is basically about space exploration and sustainability. How are these two things interconnected? Why are they interconnected? And why does it matter? There will be a quiz at the end. No, I'm just kidding. Sustainability in space increases sustainability on the Earth. It's not like the technologies we develop for space exploration stay in orbit. Those ideas, those processes, those capabilities come back down. And we can use those on the Earth, amongst ourselves, to make the world a much better place, if we afford ourselves the capability to do it. So what we're going to do is we're going to build a Mars base. Now, the Apollo program, when it first started, was not supposed to be just a one shot to the moon, put a flag, yay, and then everybody come home. It was supposed to be a moon base with orbital platforms. There was a whole gigantic program and process that was set up. And part of that process includes how in the world do you have people live on a place that's not designed for people to live? To what level of technical advancement do you need to integrate into the system? How do you provide for their biological needs? How do you provide for their quality of life needs? That way, they're not spending their entire times just maintaining their habitat, but instead they're actually doing the science and the research that they're supposed to be there for in the first place. Okay? So what are some of the biological needs, and these are pretty simple, I'm sure they always come really quick, that the human being as a creature needs to survive? Anybody can throw one out.
Food. Air.
Air. I heard food. Yes.
Love.
Water. Love. Right. So what about quality of life necessities? Things that go beyond just keeping the creature alive, but makes the creature comfortable.
Shelter.
Shelter.
Energy.
Energy.
Light.
Like climate control systems, which kind of goes in with energy, but yes.
Communication.
Okay. Clothing, right? Especially around here. I am from Orlando, Florida. This is a big difference. So you guys have it in mind. You know what's going on. So you put a bunch of scientists and engineers and techno geeks together in a room and you say, okay, how in the world are we going to provide all of this for astronauts on Mars or on the moon or somewhere else in the International Space Station, which is what's going on every single day, is that wonderful piece of technical know-how circles the planet every 90 minutes. So you've got air, food, water, sleep, medical care. Sleep and medical care, most people don't think about right off the bat when they're talking about biological needs, but if you really think about it, they're kind of important. Sleep deprivation can have some serious biological impacts negatively. And medical care, well, if you get broke, you got to get fixed. And so, especially if you're on another world or a space station or something like that, it's not like there's a hospital down the street. So, the systems that you put inside your base are going to have to be as robust as possible. They're going to have to be as efficient as possible. You can't afford to have something break. And so with that level of sustainability in mind, that's where space exploration and sustainability go together. Quality of life needs. Now the first one on Mars is actually kind of a biological need. You can't just go for a brisk morning stroll in the Martian air. You can do that on the Earth. You can live on the Earth without shelter, but shelter makes life a little bit more comfortable. It allows you to control, climate control, so if it's cold, you can keep yourself where you want to be. Clothing, education, energy, transportation, and communication, to highlight some of the prime ones. Now, education, most people don't think about, but the smarter you are about how the world operates, how to engage each other in a civilized manner, increases your quality of life. So that is those are some of the requirements that go into how would you let astronauts live in such an environment. But it goes beyond just how will they live. Because that word right there means a lot in space. Abundance is by far one of the most important words, not just for space exploration, but also for peaceful existence on this planet. I'm going to take all of you and I'm going to put you on a deserted island. And I'm going to give you one coconut tree, and that's the only food source you've got. Now I'm pretty sure most of you will stand up and say that you're very well-behaved, honorable people who are not prone to violence. How long do you think you would last in that mindset on a deserted island with one coconut tree amongst all of you? Environmental conditions drastically shape, positive or negative, our behavioral characteristics. Now, if I put the same group of people on an island with 500 coconut trees, what do you think the odds are that you're going to fight over coconuts? Probably going to play sports with them or something. You're going to have so many of them. So abundance, having more than enough, is essential for creating an environment that allows us to behave well with each other. And when it comes to space exploration, it's vitally important on, say, a Mars base to have not 100% of what you need. You need 125% of what you need, 150% of what you need. Why? Because there's no Walmart down the street for you to go shopping if you run out of something, or any grocery store chain. Everything in space exploration has much larger logistics windows, 2 years to send something there and back. You can't afford to run out, people will die. Well, actually, that same scenario applies back here on the Earth. If there's not enough of something, people can die. Same philosophies, different environment, but if you look at the way we operate the planet today, we don't really do it that way, do we? Now in space, we have technical abundance. What that basically means is we put all of our bells and whistles and innovations together in a way that we can produce the most of what we need with the smallest amount of human labor input. Why? Well, because the astronauts are not there to just maintain their habitat. They're there to go do stuff, to pursue their passion. What is their passion? To be scientists, to be explorers, to go out into the Martian soil and drive around in a cool little go-kart and dig up a bunch of dirt and see if there's life there. Things like that. Likewise on the moon. Not so much life, but other things. So on a Mars base, technical abundance is vitally necessary. The same can be said back here. Now, you go back 50,000 years ago to the hunter-gatherers that populated this planet. They lived in a paradigm of natural abundance. Really, really big planet, not a whole lot of them. So they were able to basically use the planet as they wanted and not suffer any negative ramifications because they're not having a big ecological impact. They would use a spot and then move on to the next spot. And a couple of cycles later, where they were once before, would end up going back just fine. Natural abundance. When you start looking at populations in the billions, nature's kind of going, yeah, time out. I'm kind of having a hard time keeping up with you people. And we see that happen on the planet all over the place. Fortunately, we've got pretty good brains, most of us. And so we've invented ways that basically puts nature on a higher level and allows our technical systems to use natural practices to create technical abundance. I'm going to look back here on the Earth a little bit. And we're going to look at some of the technologies that exist in today's world right now. And I do have a source sheet that lists every single piece of technology that I'm talking about. And as a scientist, engineer person, I never say anything without being able to prove it. And so if anybody wants access to that, I did not print them because why waste the paper? I can just send you an email. So you could fill out a list, give me your email address, and I will send it to you. I blind copy everybody. Nobody will see your email addresses, and I have no interest in spamming you. I'm too damn busy. On the Earth, we have air. Well, as long as we don't muck it up, the Earth does a pretty good job of providing that one for us. And we all recognize, for the most part, that we need to do things a lot cleaner when it comes with regards to air and pollutions and things like that. The same can be said about this one. Water. Likewise, the Earth has a lot. We figured out really neat and innovative ways to take the ocean and turn it into drinking water and things like that, using desalination systems, etc., etc. And then we have some really amazing new discoveries and new technologies like like portable nanomesh, carbon fiber nanomesh materials. Basically, you can take a bottle, and as such, empty, go to the dirtiest mud hole in Africa, run the filter through, and you can drink the water on the other side instantly. It filters out all the muck because bacteria can't get through that nano. The scale's too small. Water particles can, but the muck can't. Now imagine having a really large system like that that can clean up all the water for an entire village or a region or a city. Biological needs going on to food, high-tech farming, aquaponics, hydroponics are starting to become a lot better known as far as their potentials and their capabilities. The big CFS icon is my company that I just recently started. To give it to you in a nutshell, I'm going to be able to feed 1,600 people 10 different fruits and vegetables each using just a 464 square meter building that is completely off the grid, solar and wind powered with a battery bank backup. In other words, I can drop this thing in the middle of nowhere with no infrastructure and it will make food. That's quite advantageous to all those people starving to death in Africa who have no infrastructure. That's kind of the point of my company. To get these systems into places where they're dying and they don't have the means to advance themselves by themselves to this level. Now it's not just drop food and walk away. There's also an educational platform involved. We're going to teach these people exactly how this building works, to respect the tech that goes into it. We don't do a lot of tech respect these days. People just use these bells and whistles. They don't have the foggiest clue how any of them work. But the people that are going to have their lives saved from these buildings are going to understand how these systems work. And they're really not that complicated. They can be explained with manuals and tutorials and a constant process of getting these people upgraded, not only in the belly, but in the brain. Sleep. Well, that comes a lot easier when your stress is a lot less. And if your belly's full, and your water's covered, and you have a relatively comfortable biological state, sleep isn't that hard to come by. Medical care. The device that you see on the left is called the Da Vinci Surgical Assistant. This is a cute little piece of technology. What you do is the doctor sticks his head in a video game system, kind of what it looks like a little bit. He grabs these controls and he starts playing with them, and what this does is this allows a surgeon to perform surgeries at a dramatically increased precision level than you can with nubby human fingers. The incisions are smaller, the recovery times of the patients are on order of 50 to 75% faster than normal. Not only that, you can do it telerobotically. In other words, he doesn't even have to be in the same room. He doesn't have to be in the same city. He doesn't have to be in the same country. So imagine getting these systems in a mobile platform so that a surgeon anywhere on the planet or within range could basically use the internet and our advanced communication systems to save lives in places where they don't have hospitals. Now, what about tech for our quality of life? I got to know contour crafting and Dr. Kushnievis. He's a professor at the University of Southern California. He came up with this really cute system, and I got to know it because of Haiti. How many of you obviously remember the Haitian earthquake a couple of years ago? People are still living in tents. What century are we living in? They're still in tents. So what does this do? Well, this is a big robot that can build a 2,000 square foot house in 24 hours. Or, what would that, 185 square meter house in 24 hours, including plumbing, including electrical. It's a fully automated house builder. And it's on wheels, and the materials that he's invented, you can see them here on the right, basically stack layer these buildings. And because he's a civil engineer and he works with mechanical engineers and everything else, they've made this material property, this special concrete, that is tremendously stronger than what we currently have. And so it's perfectly safe and viable. There's only one thing preventing him from building a full-scale prototype to actually fully detail out all the bells and whistles. What do you think that restriction might be?
Money.
Money. Lots of capability, not a lot of finance. That's kind of dumb. Clothing and other products. Automated sewing systems. Imagine the height of independence. Instead of settling for what another clothing manufacturer says this is the latest trend and you should buy this whizzy widget or whatever kind of clothing item is out, you take a little bit of this top and a little bit of this bottom and you customize it to your size specifically, because not everyone is just a small, medium, large, or whatever. And you send this to a local facility down the street that custom creates in the colors you want, in the fabrics that you want, in the style that you want, instantly, on demand, prints out your clothes or sews your clothes and sends it to you. Or 3D printing. Now, I forgot to dig it out of my bag. Prototype. Pretty solid and robust things. And complex things with threads. And complex things like full-scale models or complex models in a couple of hours. Basically what you can do is you can put in a blueprint of a particular design, and these 3D printing systems will, in a short period of time, create what was once a drawing in just a couple of hours. And the more complicated the object, the longer it takes for it to do it. But for those of you who do get my, my source sheet, the video that I've linked, it will show you that it can create some very complicated parts out of one run, one move. It's all out of one piece. Gear systems that interconnect, you spin one and there's like 20 of them connected in a ring and it'll make them all move. And they're all perfectly interconnected. It can do very complicated geometry. If anybody wants to see these afterwards, you're more than welcome to come up and bang on them. So imagine having the capability, and this would be really advantageous on Mars, to have some of the basic stuff or materials that you need to create whatever you need, and when a part breaks or something goes askew, you just rapidly print one out really fast and you replace it. Say something breaks in your house, do the same thing. Say you want to customize and make your own dishes, do it. Because it really works just like a printer. It has 2 cartridges. Some of them have 3 or 4 cartridges of different colors. And you literally put this cartridge of stuff in, kind of like ink, but instead of ink, it like contour crafting builds the house in layers, it builds this stuff in layers. And they are getting a lot better with this. They now have 3D printing systems that can do titanium. Really complicated. I have pictures. You guys wouldn't be able to see them. I don't want everybody to have to rush up. So you can come and see the pictures of some of the titanium designs that they've made using 3D printing. Education. We live in a pretty dynamic world, and in this particular case, education and communication go hand in hand. We have the ability to learn anything, anywhere, almost any time, thanks to the internet for the most part. But we're also coming to realize that the traditional mode of education, the industrial factory line process of kid goes into grade 1 and just goes through the motions until they graduate at the end. Congratulations, you're now a cog in the wheel, go get a job. Not exactly the most stimulating way to educate children. In fact, quite the opposite, it stifles a lot of creativity in children. So a lot of leading experts are starting to figure out that the brain doesn't quite work that way, and that we need to adopt more dynamic, organic, interactive modes of learning. Not based on how old someone is, by saying, oh, you're this age, you're only allowed to learn this, but by cultivating a natural passion in them for whatever they want, and try to throw the other stuff in there as they go. And as different kids learn in different ways. A 6-year-old might be really interested in art and not care about math. But by the time they get 11 or 12, maybe they flipped and now they're more interested in math and not so much in the arts. So things change, passions change. I'll give you an example of how dynamic education is. I have an 8-year-old daughter. She just turned 8. When she was 6 and a half, almost 7, I put her on a website that I learned about called Khan Academy. Khan Academy.org. Developed by a guy by the name of Salman Khan. It is a really cool self-directed learning platform. So we put her on the math bit. Right now it's mostly the hard sciences and math, and they're trying to figure out how to get history and English and other disciplines to fall into this dynamic learning platform. But consider it a tree. And you start off at the top, 1 plus 1 is 2. That's addition 1. So you go through the real basics. Every module has like a 10-minute video. And there's jokes and stuff like that. It's not all uber serious of some authority figure in front of the room. In fact, you don't even see anybody. All you hear is the voice and you see the light pen writing on the board. So it kind of gets a little bit away from this I'm the boss, you listen to me mentality. And it's more, I'm your friend instructing you, let's just go along. So we put her on that, gave her some of the basics on how to navigate the website. It's a perfectly safe website, so we didn't have a problem with her doing her own thing. 2 months later, she's doing like 30 minutes every other day. She comes up to me and she goes, Dad, I'm having problems with a word. And I'm like, you're doing math, what are you doing with words? She goes, what's obtuse? And I'm like, obtuse? You mean obtuse? Yeah. And she runs off. Obtuse. As in obtuse, acute, right angle, trigonometry related words. So I walk over there and I look over and I go, what are you doing? And she goes, all this. That's exactly what she was teaching herself. She had already passed radians and degrees. So she had already gone through the lesson that separated the difference between radians and degrees. And the moment she passed this, she was going to start getting into sines, cosines, and tangents, and how, and Pythagorean theorem and things like that. She's 6 and a half. All right? Why? Because nobody told her she couldn't learn that, or that she shouldn't learn that. And they're now starting to use the Khan Academy in schools in California. Well, what they've basically done is they've turned the teacher more into a referee instead of a teacher. The teacher just kind of goes around the room. There's all these modules and stations, and they have Khan Academy programs on, and the kids are allowed to collaborate, cooperate, and help each other learn. And they have found 8th graders that are now doing differential equations and calculus 3. Because they can. Education is not what we are told education is. And this notion that we need to just throw more money at it is obviously a failed ideology to begin with. But it goes deeper than that. We need to change the way we teach people. Clean energy systems. Now, a lot of people know about these, so we're just going to touch base on some of them real quick. We know about solar, and they're getting better and better with solar. In fact, there was a recent article as of the 19th, I think, of this month, where they have figured out a way to use carbon nanotubes as collecting systems over the solar cells so that you don't waste as much energy due to heat and it doesn't absorb it. And they're getting orders of magnitude better in efficiency just by turning them. They used to be flat. They turned them into cylinders, and it drastically improved the efficiency of the solar cells. And not too long before that, they invented a solar cell that could work at night. Collects moonlight, ambient light, and it also collects thermal, heat, things like that, which is all part of the electromagnetic spectrum. And if it's going to be there anyway, you might as well tap it. And so they figured out ways to do that. Then you've got wind. Now when most people think about wind, they think about big giant fans sucking up hundreds of acres in these big wind farms. Those in and of themselves have their own issues. I mean, any fan of that size, as it's spinning around, you've got gravity pulling down. It's causing the nose of that thing to lean forward. And a lot of the gears on the top end of those fans end up wearing out really fast, which is why they shut down or break down, and they have constant maintenance cycles. Because gravity is not your friend when you're leaning that way. Now they're trying to lean them back, and they put little angles on them, but gravity's still pulling down on these big fans. So why don't you do that? A vertical wind turbine that's symmetrical relative to gravity, so it doesn't matter what gravity is doing because you're not leaning that way, you're leaning, well, you're not leaning at all, you're up. Now let's go a step further. Inside these bearing housings right here, instead of actually gears and bearings, let's put two magnets of the same pole. What happens when you try to put two magnets together of the same pole? It don't want it. Well, if you set up the housing the right way, you'll have your entire fan floating on a magnetic field, which means you can, and it'll move. The cut-in wind speeds are drastically less on magnetic vertical axis wind turbines. So you take these, and they also make a lot less noise. And it doesn't matter which direction the wind is blowing. You don't have to turn the fan to face the wind, because the ways these things are set up, thanks to aerodynamics and good old-fashioned physics, it doesn't matter which way the wind is going. Even if it changes direction, it still spins. I recently went to Christiania the other day, and we were eating, what was it, a shawarma? Whatever it was called? Turkish burrito. And they have one up there, and it's just doing its thing, going around like crazy. It's not like you guys don't have a shortage of wind in this place. My nose knows it. Now, how about this one right here? Let's put some vertical wind turbines built into the light poles, and that way when a car goes by, what does it do? Generate a big gust of wind, so you force the blades to go around just by having the traffic. The traffic can be the driver. Now if you put a nice little battery bank in the bottom, just one good battery that can power these lights, and let's make the lights LEDs because they suck like maybe 10 watts of power to light the whole thing. What is it?
It's the wind.
It's the wind. It probably is. So now you have a system that's tremendously more efficient. The wind's going to blow anyway, and when the cars go by, you can accelerate the charge of the battery so that at night it can run the entire thing all night long, and it's not plugged into a grid. In other words, if the local power plant goes down, this doesn't care because they're all independently powered. Now let's take this a step further. What if every single building in the entire city was independently powered? Decentralize the grid structure. We have a very centralized power system right now. You have 1 or 2 power plants, a bunch of relay stations, and if something happens drastically, I don't know, ask Japan, what happens? All hell breaks loose. Everything goes down. But if every single building has a little bit of solar, a little bit of wind, a little bit of geothermal if it's capable, a little bit of wave, a little bit of tidal, you start using all these natural energy generation capabilities. Now, holistically, we're not looking for cold fusion here. There's not one holy grail power source that's going to do everything all the time in one shot. We might get there one day, sure, but we're not there now. However, we don't really need it because we have a whole lot of clean energy systems that can be used together so that buildings can be off the grid in and of themselves. If the building is too big, and you have a house that nobody's in right now that's generating 160% of the energy that it needs because everything's off. If you have a smart grid with a quasi-AI computer system that can in real time see where the energy loads are, it can shift power from that 160% building to one that maybe is short by 20 or 30% and do it instantly. It's called dynamic load balancing. Nature does this all the time. We can have our technical systems do the same thing. In fact, on the International Space Station, that's exactly what we do. We have dynamic load sharing. Clean energy systems continued. You have the Bloom box, which is a fuel cell, an advanced fuel cell that is really powerful, very efficient. Currently, eBay, the company eBay in California, is running some Bloom servers to supplement its power needs. About 40% of its energy is coming off of this. And the primary ingredient is sand. Sand. There's a crap load of sand on the planet, so I don't think we really have a big shortage of making these fuel cells. Currently, they're running on natural gas, but they are doing research to get them solar powered or electric powered, kind of like a self-electrical electrolysis built in. So imagine they get that up and running, and they're really close to it. Now you have wind systems. That guy. And now he's hiding behind lockers. Yes, he did bring his own power system. So imagine you take all these clean energy systems and you plug it into that fuel cell system, you have one hell of a robust infrastructure for your power. We don't have to worry about energy. Now we have energy in abundance. And energy is the primary driver for the advancement of human civilization. Starting with Ugg rubbing two sticks together to make fire. We'll probably saw a lightning bolt scare the hell out of him and lit a tree on fire. All the way to the technologically advanced systems that we have today. Transportation. How do we have abundant transportation? Well, there's a key question to ask yourself. And people who live in urban environments know this already. Do you really need to have a car? Or do you really just want on-demand access to transport so you can go where you want, when you want? Now, people who live in New York, Stockholm, like that, have a really good mass transit system. I know that Copenhagen is currently digging one up right now and trying to expand the metro that you guys have. So if you have a really good mass transit system, you'll come to find that a lot of those people haven't owned a vehicle in years. Why? Because they don't really need one. It's not about having a car, owning a car. It's about being able to get around. If you design things properly, like your city systems or your transportation systems, and you use advanced technologies like this, for example, Ultra, this is a fully automated, no driver, computer-controlled car, for lack of a better term, that you hop in, punch where you want to go, and it'll run down this track almost like, think a monorail at Disney. But instead of being on a rail, it has little tires and it drives around. And it's point to point like a taxi. It's not like a subway where you have to wait for stops. But when you hop on, you tell it where you want to go and it takes you directly there. They're currently running this system at Heathrow Airport in the United Kingdom. And it's working rather well. Takes a little getting used to, but then again, any advancement that people aren't used to takes a little getting used to. Electric cars. Now I know there's all kinds of varieties, but I really like the sporty look. So you've got Tesla motors, you've got Nissan with the Leaf, all these other options are coming out for electric vehicles. It's not so much that the electric vehicles aren't capable. I mean, yeah, can they go 300-400 miles yet? No. But that doesn't matter so much if you have a good infrastructure. But we hear a lot of the political arguments and people who detract against electric vehicles, well, we just don't have the infrastructure for that. How's everybody going to charge everything? Did we have the infrastructure in place when they invented the internal combustion engine and started making cars? No. It's not like they said, no, we can't have the car yet. We got to build a crap load of gas stations first. Then you can invent the car. That's not how it worked. Likewise with the electric car. Unfortunately, billions and billions of dollars are made and lost on oil. And so if you start mucking with that system too much, you run into a big roadblock. But we have the capability. You've also got systems like this. This is from Stanford University. There's also the Google car, And I know that there is a company in Germany that I can never remember the name of that is also working on this, but it's a fully autonomous, not even remote controlled, self-controlled car. No driver. And think about this. You're having a really good night out with the buds on a Saturday and you're absolutely loaded. How many traffic accidents and people die from being Superman trying to jump behind the wheel of a car like an idiot, thinking they can take themselves home? When you could get on an app on your phone, and if you can see it, probably make the icon really big. Ask the car to come and get you. These remote taxis, for lack of a better term, can show up at any time, pick you up, and take you home. And since they're radar-driven, GPS-controlled, and they can track all the vehicles around them for like about a mile radius, and they can communicate with each other at light speed using radio systems and everything else, they'll know what the other cars are doing, and the other cars know what it's doing, and the odds of you running into an accident are 0. Anyone got maglev trains, which Asia is really up on. For some reason, my country is completely retarded when it comes to that. We are very married to our cars and airplanes. However, if you were to take something like this and really make a robust network around the entire planet of high-speed maglev trains, you could get around a lot easier than with an airplane. Trains can hold more people. It can be more comfortable. It can go almost as fast. And if you do something called ETT, which is evacuated tube transport, that's basically taking a car-sized vehicle, putting it in a tube, sucking half the air out, and you can go about 1,500 miles an hour. Because drag can be a pain in the butt as far as how fast you can go, which is why you run into issues with trains can't go too fast because they run into wind resistance, all the air. But if you put it in a tube and you suck a lot of the air out, you can go a lot faster. Now you don't want to accelerate that quick, that might be uncomfortable. But you can get up to those velocities and then slowly come back down, and you'll be able to go New York to Hong Kong in about 4 to 5 hours. You basically just kind of cross over the North Pole a little bit, you kind of come back down. ETT has an entire map laid out on how you could do a global grid of looping systems where these transports could take you anywhere you want to go, and you can take a nap and wake up and be there. Anywhere in the world, pretty much. So why don't we do that? That would be expensive, wouldn't it? Now, do we have the natural resources to do it? Yes. Do we have the technical capability to do it? Yes. Is the planet populated by enough science, techno-engineering geeks? Yes. Who would like to do that? But do we have the political or financial will to come close to making that happen?
Getting access to the resources.
Yeah. So, let's get on to this one. Communication. It's hard for us to argue against communication. I mean, you've got your tablet right there, and people have got their phones, and I Skype with my wife and daughter almost every single night. Go back 20 years and try to explain to someone that you're going to be able to hop on a laptop and do a live video conference whenever you want, halfway around the planet. That then wasn't even conceivable, but now our communication capabilities are so strong that that is actually in our phone. They have Skype apps in the phone where you can do it through your phone now. So that's not a problem. To create abundance in our ability to eat, have clean water, get around, communicate, have shelters that can be rapidly produced at a high state of safety for every man, woman, and child on the planet. We have the technical capabilities and the natural resources. So then there's a question. Can our current socioeconomic model actually handle that level of abundance, that level of sustainability? Was it ever designed to be that efficient? No. No, it wasn't. A lot of people forget that the economics that we have today were basically developed about 2,000 to 3,000 years ago. It really still boils down to markets and financial transactions. Now that started off as like seashells and coins. First it was actually trade and barter, right? 2 sheep for a cow, that kind of stuff. The world was a very big, complicated place. you really did have a have and a have-not scenario where you couldn't grow or cultivate something on an abundance level, on a robust level. So some people became this particular occupation and some people became this particular occupation. And then they would trade their knowledge back and forth through goods and services or whatever. So that was perfectly viable way back then. We don't live in the same world anymore. We're not in that level of deficiency. We are living in a world of potential high efficiency if we actually did it. So, let's do a little breakdown. What do we have now? What do we need? Based on everything I just told you, and I just went over some of the real basics of the technologies that we have today, that exist right now. None of that sci-fi, none of that needs to be invented. All of that exists right now. We have a system based on scarcity, which was relevant when it was devised. What we need is a system based on technical abundance. In the market system, what happens if you flood the market with a particular widget or whatever? The value of that goes. Now, it might have a high intrinsic value, like food or something like that. People need it to live. It has a high value for us. But the market value can be highly messed with. And it can also be messed with artificially, which means I want to make sure the price stays at a certain level, and so we're going to destroy some food, i.e. the Agricultural Adjustment Act of 1932 by the United States of America during the Great Depression. Efficient human labor as the main driver. What we need is a system based on efficient technical labor as the main driver. Now that makes a lot of sense, the human labor bit, when that's really all we had at the beginning. I mean, yeah, eventually we got a couple of ox to pull a plow and things like that, and then we started developing tractors, which really started reducing how much human labor you needed to do farming. Just look at the agricultural sector, like how many people it employed 1,000 years ago on the planet versus today. Well, look at the productive capability difference between 1,000 years ago and today. We can produce a whole lot more with a lot less people. That's where the technical labor bit comes in. We've gotten really good at inventing systems that don't have emotions, they don't need to take a lunch break, they don't smoke cigarettes, they don't care who they're serving. My food systems don't care if you play Xbox all day or if you're a rocket scientist. It will make food all the time, indiscriminately, forever. As long as it's clean energy powered and is maintained properly. Now fortunately, there are enough techies out there that love that kind of stuff that would do it as a hobby if they could. In fact, a lot of them do. How many people? There are plenty of people who have aquaponic and hydroponic farm systems in their own houses just because they like it. They think it's pretty cool. And there's a lot of people who tinker with robotics all the time because they like it. So now let's put those two people in a room and let them be the ones who they like doing it anyway. They're the ones who would make sure that the buildings and the facilities were managed and upgraded and adjusted accordingly. We have a system based on cyclical consumption for constant growth. What we need is a system based on sustainability and balance. How many planet Earths do we have? How in the hell can constant growth be the dominant model when you only have one planet?
Money.
That's later. It doesn't work. We're going to run out of stuff. Now we're starting to see that happen, by the way. It's also about making a lot of redundant systems in this thing, because in this current system, because you've got to have cyclical consumption. Which means, how is GDP derived? You just got to sell a bunch of stuff. It's all about profits and bottom lines and getting a lot of merchandise out there. In other words, you can make a really, really good phone that lasts 150 years that costs way too much. Or you build a really, really crap phone so that the poor people can afford it. Now the resources, the natural resources that go into both of those phones is virtually identical. This one breaks really fast and people chuck it. Look at the waste. Just look at cell phones as a simple example. How much waste goes into making duplicate less efficient, terrible versions of just that one product, and how many natural resources we waste on a regular basis just there. Now look at every other industry and how much product duplication and how much stratification we have in quality of product. If we actually set out with the purpose of sustainability and balance by making the highest quality version of every single thing possible based on current knowledge, and now if there's a big revelation that happens in 20 years, then you make sure that whatever you made is as recyclable and renewable as possible. That way you minimize the resource impact on the products that you create, and you can actually make more products than we currently do now to satisfy the needs of everybody on the planet. We have a system based on ownership and control. What we need is one based on usership, which is a word I made up, and open access. Ownership makes sense if you go back to the time in which it was relevant. How did ownership start? I mean, the hunter-gatherers didn't own. They actually lived in a usership and open access paradigm. They just kind of moved around and grabbed what they needed. They used the planet as they saw fit. They didn't have a big footprint on it, and the planet didn't care. The planet cares now. Or at least as far as our perspective is, it does. But when it comes to the agricultural revolution, now we have a scenario where you've got people who are tilling land and doing a lot of work on the dirt to grow food for this local region, and they don't want somebody that had nothing to do with it go into it because there is an emotional attachment to that labor. I worked hard for this farm. I don't want some schmuck coming in and taking all the food that I worked for, right? So I'm going to put a fence around it. I own this land. It is mine now. Somebody hops the fence, comes in, takes some stuff anyway. Peter Rabbit takes off. All right, that wasn't enough, so now I'm going to hire a couple of guys with sticks. Now you have police and military influences to protect the ownership because of the human labor paradigm. But I go back to the fact that my robots don't care about that. There is no emotional connection when you have technical abundance and technical capabilities, because that computer, those technical systems, they don't have that emotional conflict. They'll make more than enough for everybody, no matter what you do all day. And that's where you get to usership and open access. That goes back to the, do you need a car or do you just need to get around? That goes down to open access, things like Wikipedia, like Linux. Linux is one of the highest examples of open access, open source information sharing. It's, who does not know what Linux is? All right, Linux is an operating system platform for your computer. Yeah, Windows is one, and Linux would be another one. Windows is proprietary, controlled, closed off, can't mess with it, got to buy the next one when it comes out. Linux is open sourced, anybody can jump into the code, make it better, improve it, and it's free and downloadable for anybody who wants to use it, including all the software packages that it runs. Because this planet is populated by a lot of computer geeks who love to sit in front of code all day long, which would give me a migraine. But they love doing it, and they create amazing software packages that mimic or resemble the mainstream ones that you've got to buy. Now imagine living in a world where all the people who spent their time on the proprietary ones also contributed, in fact I know some who do, but anyway, also contributed to the open source platforms so that everybody on the planet had access to the most up-to-date, capable, and upgraded systems possible. Linux is just one example, and that exists today. We have a system based on outdated, multi-century-old ideologies and institutions. I think I've hit that quite a few times. What we need is a system based on forward thinking, adaptation, and emergence. We're always learning new data, right? We get new information. The human species is constantly learning. The earth is flat. I know it's flat. Look, if you go there, ass is going to fall off the edge. A little bit of science, okay, not so flat. Different new data, different way of thinking. Completely different look on how the world operates. Moving forward. There's no way you're ever going to get into space. Besides, it's flat up there too. Can't you see it's like there's a big glass plane over us? Everything's about at the same spot. Just some of them are brighter than others. All right? Tranquility Base, the Eagle has landed, man on the moon. Okay, yes we can go into space. New data, new way of thinking about ourselves, our planet, the universe, especially that whole turn around, look back and take a picture of the planet thing, which gave a whole lot of people a big wake-up call. So we move forward, we adapt. But look at our socioeconomic systems. Has that adapted and changed relative to new information and upgrades and new knowledge and capabilities? Not really. There might be tweaks here and there, but when you start getting to the levels of capability and abundance that we have today, it's falling apart. It shouldn't have to. There shouldn't be a man, woman, or child on this planet that suffers in any way, unless they bring it on themselves because they went hiking and forgot to pack a rope. But that's on them. What we have now is a system based on hostile competition, secrecy, and differential advantage. And what we need is something more akin to collaboration, cooperation, and information exchange for mutual benefit. It goes back to the internet. We're exchanging information all the time, and that's perfectly free. Now granted, some of the information is way off. So you got to learn to filter the nonsense, the BS from what's legitimate. When it comes to competition, I'm actually not anti-competition. It's not like everybody's going to sing Kumbaya around a campfire. Competition is okay. Two scientist friends or colleagues going up against each other to solve a particular problem is not really a bad thing in the long run, is it? Somebody's going to win. Somebody's going to solve that problem. The entire human species is going to benefit from it. And if these two scientists are ethical and educated the proper way, they'll congratulate each other and go have a beer after they're done. But economic competition kills people. Economic competition pulls resources from one area, from one group of people, over to another group of people. Ergo, starvation, then planet destruction, deforestation, yada, yada, yada. Economic competition is not really good. But don't take away my sports. Because at the end of the day, sports doesn't kill anybody. But that can. Well, that just goes into the mine, I own it paradigm. Does it not? But if you're collaborating, imagine if every single scientist on the planet or technical person worked together, instead of building missiles, bombs, and guns, decided to increase the energy efficiency of every single city on the planet and or design better cities on the outskirts, so that we have these really amazing productive capabilities all around the entire planet. It's not like we have a shortage of brain power. We just don't always use it in the right way. We have a system where political opinion, influenced by financial contributions, which we all know about, called lobbyists, dictate the ebb and flow of political operations, or global operations, to benefit a select few. Just ask the Occupy group how that one works. What we need is a system where the scientific method is used in conjunction with human experience and technical foundations to enhance the lives of all people. Now, this isn't some Terminator futuristic robots taking over the world thing. There is a human element involved. A lot of people ask about, what about AI? What about if you get self-aware technologies, robots that can think for themselves and they're almost human? Well, at that point, as far as I'm concerned, they are human. They should not be used as slave labor, and they should be treated just like everybody else. That would be the proper and ethical thing to do. But a dumb tech, what I call dumb tech, some robot machine that just cranks out something over and over again, it doesn't have feelings or emotions or self-awareness, can be used in a way with human experience and advancing knowledge to produce enough for everybody on the planet. We need to move from an old system to a new one. I consider it like an upgrade. Right now we're running Windows 1.0, and we need to upgrade to Linux. We call it the resource-based economy. Before I knew what that term was, I just called it a Mars base, because that's exactly how it would have to operate. And this was figured out decades ago. It was under a different name, it was under a different premise. But if you apply all of those foundations back here on the planet, we can do it now. So that's a cute little name, RBE. But remember, there are no utopias. There's no such thing as perfect. We're not talking about a perfect world, we're just talking about a better one. Something that's much more efficient, it's better for more people. It actually takes into account everybody and kind of gets rid of these racial divides, religious divides, geographic divides. I was fortunate enough to be on the bowling team, or the bowling league, with the pilot of Space Shuttle Endeavour, which was actually my bird, that's the one that I was assigned to, the last mission. And he had been on previous missions before. And one of the things I asked him, and I asked several astronauts when I went around the space facility in Houston, what was one of the first things you thought when you got up there and you turned around and you looked back? To a T, every single one of them basically say, it's the most amazing sight I have ever seen in my entire life, and I wish every human on the planet could have this opportunity. And there are no lines on a map. You just see the Earth. You see land masses and water, and that's it. And you know down there are a whole bunch of animals and plants and creatures and people trying to make the best of it, but we're not exactly using the right systems anymore to make the best of it. We're simply going from an established society, which is what we have now. This is how it is. This is how it's always been. As if somewhere in a book it's written, God created heaven and the earth and money and banks. Which is obviously not true. To an emergent society which adapts and adjusts its capabilities based on what we've learned, and when we reach a sufficient enough level where we can do something efficiently and sustainably, then we just go around the entire planet so everybody goes up one notch. So how in the world do you get from here to there? How do you go from this mess that we have today to something that's a lot more equitable for more people? I'm not going to tell anybody what to do. I'm not going to tell you to join this or join that. It doesn't matter. Here's what it boils down to. You could join a group that expresses ideas that resonate with you. That could be any one of the ones you see there on the list, and there are many more. Something I say quite frequently is it doesn't matter what flag you're flying on your ship. What matters is that your ship is going in the right direction. At the end of the day, if we're all docking at the same harbor, where mankind is a hell of a lot better off, then do it in whatever way works for you. Whether it's joining the Zeitgeist movement, promoting and advocating the Venus Project, the Atlas Initiative group is a group that's trying to actually build a test city, like an urban environment where you could go and visit like a theme park or a resort, where you could experience life in that kind of technically abundant world, where you actually don't pay for anything when you're in there, because there's so much of it that there's no financial value anymore to everything that's there. It's just that efficient. You could start or work for CSR companies, corporately social responsible entities. That's what I'm doing. Basically, I'm tilling the soil. I'm going to erode it from the bottom up. My goal is to make people less dependent on money for food. So that they got a little bit more money. Yay, I got more money. I have lower bills. And then what happens when you do that with energy? Yay, don't have a bill for energy, more money. Now let's do that for transportation. Now let's do that for something else. Eventually, you're going to have no bills, a crap load of money, and you're going to be going, WTF? What do I need this for? What's this paper mean anymore? My food's covered, my water's covered, I've got solar, rain collectors, I've got transport, I've got the things have been over time developed in a way to where I don't need this artificial proxy anymore. I don't need this anymore. Because it's not about the paper, it's about the resources. We use the paper to get the resources. You can get rid of the middleman if you're efficient enough to get rid of the middleman. And there are many more options. In the long run, we're all one species. We set up a lot of divides amongst ourselves. but it still boils down to one fundamental truth. We only have one Earth. If we don't take care of it, we're going to have a really bad day. Now, the planet doesn't care. The planet will go on without us. In fact, in a couple of billion years, the sun's going to expand. It's going to suck into our solar system. Everything's going to get vaporized, and then the sun's going to go nova and blast all of us and our bits back into the universe as tiny little particles, which is where we started from in the first place. That's kind of a big way of looking at it, isn't it? It kind of makes you feel, we are. So what we should do is make sure that this little brief period of time that we have is as good for as many people as possible. And we start breaking down these old school divisions. Thank you.